Okay, so we've looked at the scientific method. Now, notice what we've done here. And this is just, again, a design feature of learning. Oftentimes, the more you learn, the more questions that are opened up. So hopefully, and I know this is the case, this is generating more questions. This is generating more, maybe even more questions than answers. But I want you to don't despair. This is one of those things where it could be, you think, well, wait, we've come to some answers, but now I have more questions. But what you've done is we really have made advances, and this is just one of those things when it comes to learning, the more you know, the more you realize that you've got questions. So it's good that you're having, like, wait a second, this opens a whole can of worms. That we're opening, that's one of the purposes of these talks, is to open cans of worms. Because you need to know that these are things that you're going to have to be dealing with. So we mentioned this at the very end with in the question and answer period. How do you avoid uncertainty? We had a question, someone had a great question in between these talks that said, okay, so I can't be absolutely 100% mathematically certain about some of these doctrines. But as a pastor, I need to say things authoritatively. I can't go, well, I could be wrong about this, but like every time, and you can't do that. So this is, I think, the challenge of the church for the next, I don't know how long. I mean, I'm as Yoda said, hard to see the future is. It's always moving, but this is one of the challenges that the church is going to have. This epistemological challenge that ends up manifesting itself in a challenge that relates to authority. Okay, so you're in the midst of that. You're dealing with that, and you're going to have to pray through this, and our next generations are going to have to be praying through this. So it really is, it's very, very serious. Okay, so we looked at the scientific method, I wanted to now let's talk about more specifically, now that we have some idea of how scientists know, this notion of science somehow showing that there's no God. The number of claims of this type are legion. I mean, you just think of someone like Richard Dawkins, who was voted, 2012, I forget, the world's leading intellectual. His mom, his dad were probably on the voting committee. But so he's, regardless of his actual acuity, he's seen as a very powerful authority. So this is something we really do have to deal with, because if you're, you know this better than I do, Christianity is largely taken as irrelevant. This is one of the reasons. I mean, there are other reasons, but the fact that, we all know now that there's no God because science has shown that. So I want to give you some general principles for dealing with that. So that's what we'll do. What can science know? It's the content now. So is science the kind of thing that can say or show us or suggest that there's no God? Is it even that kind of thing? And if it is, does it in fact do that? So those are the big picture questions I want to look at. So here we have two things. First of all, science tells us things about the world, about the physical makeup of the world. Does it tell us the truth? Does it tell us the truth? Well, it seems like there's good reason to think that it does tell us the truth. And I'm going to, maybe this can be edited out of the talk, but one of the I'll bring up Dawkins again, in his typical sophisticated and classy and subtle way, someone asked him, so why should you trust science? And he says this in front of a whole crowd, this is of academics, "It works, bitches." That's what he said. That was the argument. Well, okay. Now that behind that statement is a sentiment that's very, very reasonable. You have someone like Stephen Hawking. He says, science is going to defeat religion. Why? Because science works. Science works. And you have to admit, it is hard to argue with success. You know, there's some real truth to this. You cannot argue that science is not successful. So here's the first question. Does success necessarily imply truth? Well, it seems, well, of course, it had better be true. It's doing things in the world, making these wonderful things. So the first question is going to be, if science is successful, does that necessarily imply that it always says something true? Now, let me do this. If science is successful, the argument goes, then science is true. I guess this would be the Tarzan way of saying it. Science successful, science true. It seems like there are many good reasons to think yes. There's a second question. Suppose science is true. It does tell us true things about the world. Let's say it's true down to the ground about the physical world. It says true things about the physical world, and it doesn't get anything wrong. If that's the case, then does that suggest that God doesn't exist? So here's the second question. We're taking the results of this, putting it over here. If science true, then one way to say this is God doesn't exist. So if science is true, it tells us that God doesn't exist. So notice the two steps. First of all, science, we know it's true because it's successful. And now we know God doesn't exist because science is true. So these are the two issues that I want. Another way of saying this is that naturalism is true. So if science is true, then naturalism is true. The belief that there's nothing supernatural, that only the natural world exists. Okay. If you had to say, is there an official epistemology of science? And I think there is, given the nature of science. At least this is what a lot of philosophers of scientists will say, is that empiricism is the official epistemology of science. And this goes all the way back to at least Hume, where something, in order to know that it's true, or for it to be meaningful, it has to somehow be associated with our senses. We have to be able to somehow relate it to something we see, something we smell, something we taste, something we touch, whatever, something we hear. It's got to be related to our senses. That's empiricism. Now notice what that does in many cases. So if you use that and take that seriously, if God is a spirit and doesn't have a body like men, can you see God with your eyes? Well, no, he's not the kind of being that you could do that. But if empiricism holds everywhere, then you've got a problem with God. So empiricism, all of a sudden, I mean, just keep that in mind. But empiricism isn't crazy when it comes to science. So lots of things that you do with science use mathematics. But how do you know that mathematics works, that it's true? Well, it usually caches itself out or manifests itself out in something that we can see, something that we can observe. The observations have to match the math. And if they don't, then bye-bye math. The math is gone. It's no good. So you can see how seeing is believing, and that empiricism really makes a lot of sense. So it's not like empiricism, it's not like using empirical justification is always a bad thing. So we have this, and notice how that gets back to the observation theory distinction. What do you observe? Observations or theories? Well, that's pretty clear. Observations. If empiricism is true, and you never see a theory, you never observe it, that creates an instant problem. Because most of science really is theoretical, theory. It's the things you infer, not the things you observe. I mean, it includes the things you observe as well. But what if I'm an empiricist and I go, okay, well, I can't, I don't see general relativity. I don't see Newtonianism. This is one of the biggest issues in philosophy since the scientific revolution. And it's largely in part due to David Hume. So empiricism, the official epistemology, creates some issues, goes back to the observation theory distinction. Now the first thing I want to do, I want to give some reason, as crazy as it might seem at first, to think that this doesn't always apply. That sometimes it's not the case that success means truth. So I want to drive a wedge. So think of it this way. So you have success and truth. Usually we think of them together. What I want to do is I want to show you that there are times when they can come apart. And you can have success without truth. Now, not always. So I'm not saying that success and truth never go together. I'm saying that sometimes they can come apart. That's going to be, for the next few minutes, I want to give at least some reasons for thinking that. Now, okay, so what counts as success? Money? Is it what would count as success? Well, typically success means you match observations. Remember, when it comes to empiricism, you want to match the observable world. If your math gets, math says that something like this should happen, and you go and you look, and this doesn't happen, then the math is wrong. So success counts, and some philosophers of science will call this empirical adequacy. It just needs to match the observations. That's success. And if you can do that, how about this? If you can't do that, if you can't match success, if the theory can't match it, then the theory's bad. So success means empirical adequacy. It matches what we observe. Of course, you already know that there are multiple theories that can match observations. So given a set of observations, you can have multiple theories that match it. And that's why science can be so fun and entertaining, is because of the competition amongst theories. So this underdetermination creates a problem with this empirical adequacy. So you're going, okay, given just the notion of matching observations, I can have 2 or more theories that are equally successful. And that has occurred throughout history at specific times in scientific history, where you'll have 2 theories that are equally good in matching the observations. And so then you have kind of a crisis and lots of debate, and you have, say, Galileo, or downstream you have Einstein, and then eventually one takes over. Science, the history of science, is littered with the corpses of dead theories. It's littered with the corpses of dead theories that were once very successful, that matched observations very well, made wonderful and surprising predictions. So you have things like, well, we've already seen Copernicanism, right? I mean, that's something that was that overtook the Aristotelian or the Ptolemaic view. The Ptolemaic view was wildly successful. In fact, sometimes pilots will still use, you're still thinking of the Earth as center, as the center, and it's stationary, and I mean, it's still useful for navigating. But it made all manner of accurate predictions for over 1,000 years. Confirmation after confirmation after confirmation. It was wonderful. And it turns out it's false. It was wildly successful. Turns out it's false. The phlogiston theory of chemistry, where it wasn't that we were somehow having a chemical reaction of the fuel and oxygen. There was this stuff that gave rise to the combustion. And you could predict, you could make, there were certain predictions that you could make in certain ways that theory worked. It was successful, and it turns out that it was false. Another one, I'll just mention this last one, it was the theory of ether. In the 1800s, so light is, sometimes it has the characteristics of a wave. Sometimes it has the characteristics of a particle. But waves need to travel through some medium, like water or sound waves, air. So think about this, is, I'm moving some air molecules here, creating a wave that's coming at you very fast and interacting with your eardrums. But there's a medium that it required. Well, it was thought that light required that same medium, and the medium wasn't air, because light can travel through space. The medium was this really thin, rarefied substance that actually pervaded all physical objects, including space, but even physical objects, called ether. And it turned out that ether theory was so successful in that it gave such good results and gave such good confirmation of our observations that at one point, and I forget if this was Lord Kelvin or some, Kelvin said some really wonderful things. It was J.G. Thomson. Anyways, so, some bigwig in physics said, look, the ether is really the only physical entity that we're confident of. The only physical thing that we can be most certain of. And in fact, at the time, you have the other around this time, this is the 1800s, where the ether theory is being used, and they're pretty much thinking at this time in history that physics is just kind of wrapping up. We're just getting to a few mopping up operations, but we're kind of got this down. So if you're a clever physicist, or how about this, a clever student, don't go into physics. And this was told to a famous physicist who ended up ignoring the advice and going on to help create quantum theory. You know what? You ought to go into something else, because it's really kind of almost done. All the real work's been done. Well, it turns out that there is no ether. Okay, so there you have it. And it made remarkable predictions and empirically adequate. So there's this history of success and truth coming apart. Major success and truth coming apart. But come on, that was the past, right? I mean, we know a lot more now. And so our current theories, and excuse me, this is something that's so important. Remember I gave you an overview. You became experts at physics in the last one. You know all of physics. Newtonian theory gave way to general relativity and quantum mechanics. There's no way to overstate this. General relativity and quantum mechanics are so wildly successful in terms of their predictions and their measurements and their accuracy that it's anytime you try to explain it, you think you're just speaking hyperbolically. So Richard Feynman, he was a second generation quantum physicist in the 40s and 50s. He says this, look, the quantum mechanics, some of the things that we can measure are akin to measuring the distance between New York and Los Angeles to the accuracy of within a single human hair. Like you can measure that distance and you're only off by maybe plus or minus a human hair. I mean, and we might not be surprised by that, but we ought to be. That you just think, yeah, right. But if that's true, that's remarkable. But here's the thing. I mean, well, what you would think, and this is something called the miracle argument that links success to truth. If quantum mechanics, for example, weren't true, didn't give us the truth about unobservable reality. Now remember, much of what quantum mechanics says is about particles that we can't see, quarks, electrons, things like that, that you just, and maybe even theoretically could never observe. But it gets the observable world right. The miracle argument is this. If quantum theory were not true, it would be an absolute and utter miracle that it would get things right. I mean, and that makes a lot of sense. It's so accurate beyond anything we've ever come up with. What are the odds that it's going to be wrong? It would have to be some sort of miracle. Well, here's a couple of things I want to point out. There's something. Let's take a little. We'll take in a little sidetrack here. We'll do some philosophy of science. There is actually a very, very popular way of looking at scientific theories that goes all the way back to Plato that denies this. Plato himself denied this connection. He says as long as you get the observable things right, a theory doesn't have to tell us the literal truth about what goes on behind the scenes, because you couldn't know anyways. That's called instrumentalism. And it's called instrumentalism because they use science not as it's a tool to predict and understand observations, but not to get at the truth behind those. So it's just a tool. It's an instrument to navigate and control the physical, observable world. But it doesn't tell you the truth behind the veil. And that's okay, because who would know? I mean, you'll never know. It doesn't matter anyways. You never get to behind the veil. You might think, well, that's a crazy view, and scientists today They really do think they're getting at, when they say there are electrons, doggone it, they mean there are electrons. It's not just a nice story that helps explain what goes on in the observable world. Strangely enough, when Einstein came up with his general relativity, say 1915, when he comes up with this, he was actually an instrumentalist at the time. And when he presented this paper, he's saying, look, space and time, they're really not objectively real. So he was this instrumentalist. He later turned into what's called a realist, where he said, you know what, this stuff really is telling us the truth. He kind of got, as you get older, you become more sensible, and you throw away the wild ideas of your youth. You become less radical. Well, that's kind of what he's known for. People think, okay, well, he just kind of, he lost his courage and all, but he became a realist. But when he came up with general relativity, he was an instrumentalist. He did not think that there was this connection necessarily. Now, maybe it could have turned out to be true, but it certainly, he didn't think it was. But even more telling is within the next decade or so after 1915, when you had this development of quantum mechanics. And quantum mechanics isn't talking about the large or necessarily the fast, but the tiny, subatomic world. Many of the founders of quantum mechanics, when they started looking at the math, and this is a fascinating period in scientific history, just how they came up with it, and it's starting to blow their mind. I mean, like, the notion of reality became, it started to move. And so you have some of the founders like Niels Bohr, some of the founders of quantum mechanics saying, look, the mathematics works when it comes to the observable realm, but it's not really telling us the literal truth behind the scenes. So you really can't, we tend to picture atoms as like a little solar system. That's a heuristic that, well, first of all, quantum mechanics wouldn't even say that anymore because you don't have electrons in a single location. I mean, you can't picture an atom. In fact, it's so spooky and crazy that it seems to defy our ordinary laws of logic. And so there was a proposal that we should have something called quantum logic, where something isn't, it's either true or false. It can be true, false, and both. It gets rid of the law of the excluded middle. So some of the founders of quantum mechanics are instrumentalists, and they don't think that there's this connection. And yet, there's certainly this. And today, that tends to be the way people use quantum mechanics as a recipe. The math everyone agrees on. The interpretation of the math, as it was telling us behind the scenes, people don't agree on that. Physicists don't agree on that. But it's even worse for this connection. So remember, we had quantum mechanics and general relativity. They are a pair that makes up our physics, contemporary physics. It's a match, a beautiful match. Unfortunately, they don't get along always. And sometimes they contradict one another. Sad to say. So there are some physical situations where quantum mechanics and general relativity give contradictory results. But you know what that means? At least one of them is wrong about some things. Could be that both of them are wrong about some things. But this this inability to get along sometimes and to contradict one another is well known. You may have heard of something called string theory. String theory just is the next step. Trying to fix, I mean, no doubt that a lot of the, is going to carry over, some of the truths we've learned here are going to carry over, but string theory is going to supersede, or at least it's a candidate for superseding general relativity and quantum mechanics. So you're now today, this is a string. Okay? You may have heard of M theory. M theory is a form of string theory. By the way, I wish we could talk about this. The whole notion of the universe being mathematical came from the Pythagoreans, who, according to legend, discovered that by seeing the mathematical intervals on a string. That's how it all started. And now we're going back to the world being made, the universe being made up of tiny little strings. Now that's felicitous. I love that. What a great story. So here's the point. The point is, these are obviously not, these are wildly successful, but in some sense, they're not always true. So again, I'm driving a wedge between here. So what's the point? Okay, so I've driven a wedge. Truth and success can come apart. So if science gets it wrong sometimes about the unobservable physical world, why would we believe it if it tells us something, when it tells us something about the supernatural world? Remember, it goes back to the question, science has shown that God doesn't exist. So science must say, it tells us about the unobservable world, there's no God. Well, I think at this point, science is not getting it entirely right when it comes to the physical world, much less the supernatural world. Well, I mean, do the laws of physics even hold? So this notion here of success in truth, even if science happened to say, you know what, there's no God, there's some reason for thinking, well, okay, that's what you're saying now. I'll wait until the next scientific theory and see what that scientific theory says. However, does science say, let's suppose science is true. Let's suppose that science says everything that it says about the unobservable world, quantum mechanics, what it says about electrons and quarks and gluons, what it says about bending space and time, what general relativity says, space actually bends. Let's say all of that is 100% true. We finally arrived. Does any of that suggest that there's no God? So notice we've gone to the second question, and I am not going to spend, thankfully for you, I'm not going to spend nearly as much time on this as I did on this. But suppose science is true, does it tell us anything that suggests that there's no God? Well, it's hard to see what that would be. Take, for example, here's an example. Lawrence Krauss has a book called A Universe from Nothing that came out, I think, 2012, where he says, and Dawkins loves this book, Krauss says that science finally answers the ultimate question, why there's something rather than nothing. And you might think, well, this is one of the questions that makes people roll their eyes when it comes to philosophy, and you're thinking, why is there something rather than nothing? Oh, come on. But it really is a fundamental, and in fact, it might be one of the most fundamental questions there is. Why is there a universe rather than no universe? Krauss says this, quantum mechanics tells us that you can get something from nothing. You can have, well, it wouldn't be creation ex nihilo, it would be poof ex nihilo. Yeah, I don't know what it would be called. It wouldn't be creation because there's no creator. But you can get something from nothing. And it's all due to quantum fluctuations. There are lots of problems with this. Krauss doesn't even understand the notion of nothing. Well, in fact, we don't even believe in creation ex nihilo, strictly speaking. What we mean by creation ex nihilo is that there weren't pre-existing materials like Plato's demiurge had to use, like a clay that was already there. It's like, well, let's see what I can make with this. I'm stuck with this. Well, God wasn't stuck with any stuff, pre-existing stuff. So that's why we say creation out of nothing. It's really creation, but not from some pre-existing material. But it didn't come from nothing. It came from God. God is not nothing. He's the opposite of nothing. So creation ex nihilo is a misnomer. And Krauss gets this all confused. But let's suppose he's entirely right. Notice what I've been doing at each point. I've been giving lots of concessions. I'm going to give another one. I'm going to say, let's say science is true. And let's say that Krauss is right and you can have something from nothing, and that it in fact comes from quantum fluctuations of the vacuum. Poof. Let's say that's coherent. Does that show, well, he says, look, there you don't need no God. That's bad grammar in the US, just so you know. I know that. You don't need no God for this. Well, does that show at all, does that suggest that there is no God? Would the Big Bang suggest that there's no God? It's hard to see how. God uses means all the time. I mean, the Earth's gravitational force pulled this down. Actually, according to relativity, is space curving, but we'll forget about that. The Earth's gravitational force pulled that down. I know what caused it, therefore there's no God. I see some vehicles out there. I know what makes, I've seen them move. But you know what? They don't move on their own. There's something inside. If you lift up the hood, there's an engine in there. No designer. Therefore, there's no, I've seen what causes it, right? I've seen what causes the motion. Therefore, there was no need for a human to have designed that. Well, that's a really bad argument. Similarly, when it comes to quantum fluctuations of nothing. Let's say that's all true. There's absolutely no reason to think that God wouldn't have used or couldn't have used quantum fluctuations of nothing to create. Okay, so that's just how he created. Similarly with the multiverse. You've heard, I don't know if you've heard of this, but you are amazing. And the more I get to know you, the more amazing I think you are. But just as humans, you're amazing. You're freaks of nature. There's no way to account for you in all of your amazing abilities, much less just living, but your cognitive faculties, the way you can think, the way you can talk, all of that. How am I going to account for that just by natural processes? What are the odds that the universe would be just right for everything to work out over eons to form you? The laws of physics are just right, the laws of biology are just, everything's just right. Well, here's how, and someone like Dawkins is very, very aware that this is so unlikely to happen. So here's how one of the most common answers nowadays for naturalists to how to explain these massive improbabilities. There are countless universes with different laws, and there may be something like anywhere from, I don't know, 10 to the 500. That's a 1 with 500 zeros. That's more than all of the, I forget if it's all the known atoms in the known universe. But there may be even an infinite number of universes. So 10 to the 500 universes, more than that maybe, but there's enough to make it such that the dice has been rolled, they've been rolled enough times, 10 to the 500 times, that you're eventually going to come up with a universe that produces humans. Okay, so that's that's the multiverse. And that seems to tame the probabilities. Let's suppose that it does tame the probabilities. Okay, we'll give them that. Okay, so there's this many universes. Does that show that God doesn't exist? Is there any reason to think that God could not have created that many universes and put us in one of them? Now, of course, as Christians, we're going to think things went differently. But when it comes to just belief in God, a designer, a creator of some sort, why think that a multiverse would say anything whatsoever against a creator or a designer? God just happened to create that way. There's no reason to think that he didn't. I mean, we'd have to have an argument for that. Just the fact of multiple universes doesn't mean that there's no God. So notice what I'm doing here. I'm saying that just because science is true, if it is in its entirety, doesn't mean that God doesn't exist. So neither of these follow necessarily. There are good reasons to think that both of these statements are in important cases false. So science, you'd have to really want science to show that God doesn't exist in order to ignore all this. You'd really have to go, okay, yeah, you're right, but yeah, I still think that science shows that God doesn't exist. Did you not hear what I just said? I mean, maybe God, notice what I haven't done. I haven't argued that God exists. None of this has argued that God exists. I think there are arguments for it, the user-friendliness of the universe. There's all manner of arguments for God's existence. This isn't one of them. This is just saying there's no reason to think that science has shown that God doesn't exist, which is that's what people are assuming when they ask what you're doing and you say you're a pastor. They just look at you with a blank stare. They wonder, what on earth, what are you they think of it as something like maybe you're a druid or something, something that's just so irrelevant and weird and wacky. Well, part of the reason they think that is because they think that these things are true. So, come on, guys, we all know that there's no God. Just like we know that there are no druids. Okay. All right, any questions?
Yeah.
Yes, Alex.
Sorry. It seems to me that people who are thinking are not necessarily thinking that because science is successful, then science is true, and then that means that God doesn't exist. It's rather, it seems to me that they're kind of applying the inference to the best explanation. So if they don't think you need God to explain what you observe, then for them that would be appealing to some kind of weird, unnecessarily crazy explanation.
Right.
Like we would say someone saying we came from aliens, that's you can't prove it's not true, but it's just not the best explanation.
Right.
And so, and the reason I'm saying this is because we don't observe supernatural things. That's not ordinary.
Right.
So most
right. Yeah.
So do you see what I'm saying?
I do. And so the question is this. It doesn't seem so much like people are making this sort of argument. What they're doing is they're saying, look, given what we observe, we have possible explanations. One is atheism, one's theism. Well, I can account for everything with atheism. And I think people do make that argument quite a lot. And so that is one way of arguing for atheism. You think, okay, well, this is just the inference of the best explanation. And I think we would, and then we counter by saying, okay, well, if I'm going to present an argument, I would say, no, this is the best explanation. I'll look at mathematical design. I look at all of these things, the moral argument, and I say, no, the best explanation is that there's a divine mind. So I think you're right. But then there are also countless arguments of this kind as well that says we've actually shown that there's no God. In fact, most of the most vocal atheists argue this way. They'll use that argument as well. So those are two different arguments. One's this one, one's inference of the best explanation. Sometimes they can overlap, but this one is made, this is a stronger argument, right? And now, well, how about this? This has a stronger conclusion. That also makes it a little dicier. The stronger your conclusion is, the more likely you are, the easier it is to maybe defeat it. But this is the one that has been crowed from the rooftops since the new atheists arrived. Well, actually, it's long before that, but they've been particularly vocal, and they've sold a lot of books saying this. So I agree. And so we do need to keep that in mind too. And so there would be another talk, if I had more time, where we would go, okay, let's look at that argument and see what is the best explanation, even given their view of best. What else? Jonah.
Just to comment on this, you have a hypothetical syllogism here where we see science is successful, or basically you have a pragmatic argument. Science is true. If science is true, therefore God doesn't exist. And it seems that that's the argument we hear from a lot of new atheists. Richard
Right.
Dawkins, for example.
Right.
These guys are not good epistemologists. They're bad philosophers. They may be good scientists, but bad philosophers.
Right.
But there are some good philosophers. I'm thinking of people like Paul Boghossian, not to be confused with Peter Boghossian, but Paul Boghossian, who's a well-known epistemologist today.
Right.
And he's getting to the same conclusion: God doesn't exist. But instead of taking a pragmatic approach, he's actually saying, no, science, we don't believe it just because it works. We believe it because it corresponds to reality. So he's taking a traditional kind of correspondence theory of truth.
Right.
But again, he gets to the same conclusion. So I just wonder, and maybe this is more of a comment than a question, but I think it doesn't almost really matter even where these scientists start. They're going to always
end up here.
God doesn't exist.
Okay, so the question is, some people make some good philosophers who are atheists make the argument that it's not so much that science is successful, but that it corresponds to reality. Now, here's how we would answer that. Remember how I defined successful, how it corresponded to reality, and how do we know that it corresponds to reality? What part of reality does it correspond to in order to be successful? The observable part of reality. So I would push back on Paul and say, look, that's what I just said. I mean, his argument is this because he's saying that success is corresponding to reality. What part of reality? The observable part. Anything else? Okay. All right. Well,
thank you so much.
Yeah, sure.